This tutorial is going to be based upon the Inworksive app, which was made by the Inworksive team from Chile. They did a great job creating their app with the idea of matching people with disabilities with employers. They used machine learning for kids to create their machine learning model. And what they did was take words that would be different things that the employee was looking for, such as physical modifications, such as ramps or elevators, assistive technology, those kind of things. So it took those words and trained the model on matching based upon the words that the employee input, matching it with, and they had 3 example employers. In recreating the model for this tutorial, it became apparent that trying to use this method wasn't giving a high rate of accuracy because of the number of words that were being used. If you didn't match a lot of them, you weren't getting high accuracy. But you would necessarily need a lot of those words to describe what the employer was offering. So what I did was take this idea that the Inworksive team had, and I'm going to show how we can move this a little bit along to a more substantial model by using some of the tools such as a Jupyter Notebook and Streamlit. So we're going to kind of move this to the web app, which will allow us a little more flexibility in terms of the type of model we can build with more information about the employers and give more options for the employee. So what we're doing is taking this initial prototype and we're just building upon it. With the help of, in my case, I used the Gen AI tool Claude, which was very helpful in terms of giving me both ideas on how to proceed with this and also the code behind it.
So let me just, as we go through, I'll kind of show the prompts that I made and what Claude responded with. So I initially started with, my problem that I wanted to come up with a machine learning model to match potential employees who have disabilities with employers who would be a good match. I want to ask a series of questions of the potential employee that would give them a prediction of which employer is the best match. What are some questions I could ask, and how would that tie to an employer? Claude responded with these specific areas, which are great things to ask: job skills and experience, accommodation needs, work environment preferences, career goals, transportation, industry. And then this is the kind of the big thing is accommodations, work environment, management approaches, flexibility, etc. So these are all important to people with disabilities.
So my next question to Claude was,
is AI really the answer? Should I just do a quick match between accommodations and that kind of thing? So that would be a rules-based matching system. Claude came back with, yeah, this could be a good implementation. And then I said, well, what would the benefits of machine learning model be over this? Claude gave me some good reasons why you might go with an AI model.
So the first step in making your machine learning model is obviously coming up with the data set. Now, finding data on employers and what modifications they were willing to give their employees was very difficult. I did a lot of searching online, and you couldn't really find, or at least I couldn't find, that information easily.
Because of this, I said, okay, let's go ahead. How would I start building the model? What could I use for a data set? This I had not thought of. I was looking online for data sets, figuring out where could I get this information about particular companies. It came up with this idea of synthetic or simulated data. And in fact, the Inworksive group themselves used synthetic data for their machine learning model in machine learning for kids. So then I'd say, well, how would I start this? And define your variables, create distributions, and here it already started giving me some code. Generate the profiles, generate employer profiles, and then match the two. And then generate a final data set.
Based on the recommendation by Claude, I decided to code it locally on my computer. So I'm using Visual Studio Code. This can be done in the cloud or anywhere. And I wanted to create it using a Jupyter Notebook. So the main idea was to create the synthetic data that would create our data set, which we could then use to create our machine learning model. So the outcome is going to be these 3 CSV files or spreadsheets, one for employees, one for employers, and then one for a match between those 2. I'm going to quickly go through this code. I'm also going to supply the code for you in a GitHub repository so you can download this yourself and go through it. This first cell here is just setting up our libraries. Note that you might have to install some of these, especially this faker. Faker is the thing that's generating our fake data. I use Claude a lot with some of these issues that I came across, especially setting up VS Code and running into issues with installation. Claude was really helpful in this regard. Moving on, just setting up some general things. So the disability types, these were just general possible disability types an employee might have: mobility, vision, hearing, cognitive, psychiatric, and chronic health. And then these weights, which are based on approximate real-world distribution, again supplied to me by Claude. And then these are some example accommodation needs that an employee with a disability might need. And then for work preferences, again, you might have 3 possibilities: fully remote, hybrid, or in office, and those also have weights. The first step was to generate the employee profiles. Everything was really generated randomly, so using this NP random choice. So we have the disability type, their experience in years, so we did a range of from 0 to 21 years of experience, and then their education level: high school, associate, bachelor, master's, and PhD. And then for each of the disability types, a random choice of the modifications they might need. Not that they would have all of them, but we choose a random amount to put into an array for that person. And we did this for each of the different disability types: cognitive, psychiatric, chronic health, hearing, vision, mobility. And then work preference was also a random choice. And then we would append this to our data frame, which we would then return. So this particular function creates a data frame of random employees. And then we did the same for employers, different features, but aligning with the whole data set. So there would be an ID, a random company size, small, medium, or large. We chose some industries to choose from: tech, healthcare, finance, retail, and manufacturing. Made up a fake city, and then the remote policy would be remote friendly, hybrid, or in office. Those were all generated along with the available accommodations. So for each employer, we wanted to say which accommodations were they providing for employees. So again, randomly generating an array and setting up what the remote policy is, so whether or not they were open to remote work. So this generated the employers, and we've got 200, and we had 1,000 of the employees. And then finally we did a match. So we want to go through, and this is a rules-based matching, somewhat random, but mostly rules-based. So we went through what we currently had, and for each employee we iterate, and then for each employee we looked at every single employer. Then we compared their accommodations, and if there was a match, we gave them points. So we could see here that the score, we're adding a match times 50, so we're giving them points for that. If they were aligned on the remote work option, remote, hybrid, or in office, we added something to their score for that. And then we did do this somewhat randomly. So you get a success probability, which is their score divided by 100, so that's a percentage. And then we did a random choice of 1 or 0. So this would be like, yes, it's a match or not. So we wanted to generate whether it was a match or not, and then generated a new data set or a spreadsheet, which is the employee ID, the employer ID, the match score that they got, which is their score, and then the successful match, which was a binary 1 or 0 based upon this randomness here, as well as the score. And then that would return that data frame, third data frame. And then finally what we had to do was we needed to output these to a spreadsheet. So this just takes the data frames and outputs them to a spreadsheet, and we can look at those here. So this is our employees. You can see the ID, their disability type, their experience in years, education level, accommodations that they need, and their work preference. So an example would be ID 1, their mobility, disability, 20 years experience, they have a master's degree, they only are looking for remote work, and also they've got a hybrid preference. Versus this one here, say number 5, cognitive disability, 15 years experience, associate's degree, and these are all of the modifications they're looking for. So a much larger set of modifications, and they're looking for hybrid work. So this was all randomly generated. Employers, and we've got 200 of them, so we've got an ID of 0. It's a medium-sized company. It's a manufacturing company. This was the location, Rasmussenshire, so these are just made-up names. Hybrid work policy, remote policy, and then these are all of the modifications that they are willing to give. Versus, say, this one, number 2, it's a large company, healthcare. It's in East Kelly. They want people in office, and interesting that they'll allow remote work and assistive technology. So some of these you could say aren't quite aligned. But these are the employers, and then the matches is a much simpler spreadsheet. You've just got the 2 IDs, so the employee ID, employer ID, the match score, which is a percentage. So you can see 0.8, so 80%, 50%, 0%. So these are all the percentages, and then this final one is the successful match. So it's either a 1 or a 0, whether it's a good match. We're really going to focus on this one, though, the match score for our data set. So that was that step of creating the 3 spreadsheets that would then become our data set. I have some extra cells in here where I was just printing out information for myself. Okay, next step is creating the model. There was a lot of back and forth on how to do this, how to combine the information between the 2. So this is the final version of what we came up with. So really this boiled down to one function and then calling it. The first thing was to prepare it. And what this function does is it takes the 3 spreadsheets or data frames and it creates a single data set from those 3 spreadsheets. So all of that data we're going to turn into one large data frame or row of information that we can then create our model from. Let's just go through what this does. This is just setting up all the accommodation types, and then we're going through the matches, which is the data frame, and it gets the employee and the employer from their respective data frames. So it gets the ID for the employee, it looks it up in that data frame, gets the ID for the employer, and looks up the employer information in that data frame. So we have all the information for both the employee and the employer. And then it pulls out these basic features: the disability type, the experience in years, the work preference. These are from the employee, and then from the employer, the company size, the industry, and the remote policy. What this is doing down here is adding all the accommodations, but instead of doing it in words like we have here, we need to turn it all into numbers. And that's actually what this is referring to, this one hot. One hot is taking string data and turning it into numerical data. So for every accommodation, we're setting up a column. And then within the column, it'll be a 1 if the employee is looking for that accommodation, or a 0 if not. So that's how we're turning all those words into numbers. And then we do the same for the employer. So if they're offering that accommodation, we'll have a column for them that is a 1. If they're not offering it, it will be a 0. So for every accommodation, there's an employer column and an employee column. And then we add that to the features by adding these columns: emp needs, whatever the accommodation type is, and then employer provides. So we've got a whole set of new columns in our data set. And then we also grab the match score from the matches database. So whatever that score was that we gave them, and then we append that to our training data. So this is our new data set that's going to be used to train our model. And now here's the main cell for actually creating the model. We poured a bunch of libraries from the scikit-learn that's going to help us build it. We call our function up above prepare training data with one hot, which is the one we just went through. This is just to print out what it looks like. Then we've got categorical features. So this is just defining what the categorical features are within our data set. And this is to turn these things into numbers as well. So remember that we want everything to be numbers and no words in our features in order to make our model. We're using this one-hot encoder. So just like up above, we call that one-hot. One-hot encoder encodes everything from words into numbers. And in this case, we're going to use the same thing. It's either a binary 1 or 0. So once the data has been pre-processed, we split the data into features, which is everything but the match score. Our target is the match score. So you basically drop that to create your features, and then that is your target. The next step is to split it. This did not initially happen, and I had at some point I looked and I was like, where's our testing data? So I went back to Claude and asked the question.
It had forgotten to give me the split so that I have 80% training data and 20% testing. This split is essential. However, it didn't give it to me initially, so I had to ask for it.
That's one step that I had to remind the AI assistant that I needed that. It had forgotten to give me that code. In terms of the model that I was going to create, because we're going with this match score, I went back and forth on whether or not to just use that in our matches, this final thing, successful match or not, a binary, which would be a classification. So yes, a match, or no, not a match. So that's a classification model. But what we actually ended up doing is create a regression model. So a regression model is based upon the match score. So it gives you that number, which is a continuum or a scale. This graph shows a little bit how it works. So the binary classification would be a match, which gives you either a 0 or a 1. The regression model gives you a continuum. So this would be the match scores, which would range from 0 to 100%. The first one I tried was this random forest regressor, but something didn't look right, so I went back to Claude.
I looked at it and this didn't look right to me. A mean squared error of 0 and an R squared score of 1. So I said, this doesn't look good to me. And in fact, it did tell me that that is not good, that it's actually memorizing the training data instead of learning something. Some solutions: add some noise, make your model less powerful. I adjusted the pipeline and it did give me a different number for both of them. It returned with the fact that this looks much more realistic. And then I asked, would adjusting the pipeline more up make it more accurate? I liked that it gave me different options each time. So increase the model complexity. So that's the actual algorithm. And then with the parameters, and then try more advanced algorithms. So this is where it offered this gradient boosting regressor, which that's the one I decided to try. And I said, okay, these are the numbers I get. Great improvement. Explained what each of these numbers meant.
So that's why I eventually went with this gradient boosting regressor as my algorithm for training my model. Here it's simply fitting the model on the training data, and then you use it to predict which, with the testing data, these are the two metrics that I used based, again, on Claude's recommendation. So the mean square error gives you the difference between the expected and the actual result, right? So what you would expect and what you get. So you want a low number there, right? So you want those to be close but not 0. And then the R squared score is your accuracy score. So that's going to give you a percentage. And so let's just kind of look at what we get here. So the mean squared error, and this is with the gradient boosting regressor algorithm, was 0.007. So a very small number. Our expected and actual results or numbers in the end are close. The R squared score is 86.5. So that's 86.5% accuracy. So those two numbers are really good. I did ask Claude to explain these two to me, to give me what they mean, and to tell me whether or not that is, in fact, a good number, and it did that. This up here is just printing out the columns. I wanted to see what all the columns are, and that shows you what the columns are of the data set that generated the model. And then down here is just more printing out of information about the data sets. And then the final thing we had to do was we can create the model, but because we're going to use the model in a web app, I needed to export it and I knew that I needed a pickle file. I asked Claude to supply me with that code, and so this is it. It's just the output is to this file, disability employment matching model.pickle, and then I'll be able to use that pickle file in my code for my web app. So next step, I went back to Claude.
I asked it what are some low-code options for making a web app, and it came up with Streamlit as a number one. It automatically generated that as a first step, and the fact that I was in this thread, if you're on a free tier with one of these, sometimes you're going to get stopped, right? It'll cut you off after a certain amount, so you might just have to be patient and come back a few hours later where you'll get more credit. Otherwise, you have to start over, and you'd have to start over in a new thread by giving it the context again. But the fact that it had all of the previous interactions with me, it knew what I was talking about. So it was able to generate automatically some code for me. It gave me a couple of other options, Gradio, Anvil, which I did check out, but I said, okay, I'm going to go with Streamlit.
So the next thing is Streamlit. We're going to use the Streamlit website, which is share.streamlit.io. So you want to log into that. When you log in, make sure to log in with your GitHub account. So you want it to tie to GitHub because I'm going to be doing this in the cloud. So I've logged into my GitHub. I'm actually using my personal account just because I'm going to fork the app from the Technovation account. So I'll show you how to do that. So logging in, open a new tab, and I'm going to put in the URL of the matching app that I made with the Technovation account. So here it is. So this allows you to run anyone else's app that's a public app up in the Streamlit website. This is the one that I've made. This is what we're going to work on. So just to show you how it works, you can choose a particular disability. You could say, I've got 11 years experience. I want a hybrid work situation. I'd like to work in retail, and I want a flexible schedule and possibly modified training materials. And if I say find best matches, I'm getting, oh, and I've got these, there's still debugs in here, but it gives me the top employer matches based upon my input. That's what it looks like. Because we're logged into GitHub, I can say fork, and it's going to fork and deploy. And what we want to do, open GitHub code spaces. And let's just say Technovation. You'll name this whatever you want it to. I'm going to say open GitHub code spaces and fork it. It will open this up in Visual Studio Code and also run the app for us. So it will open all of that up for us. Okay, so when it finally loads, this is what you'll get, and this is the Streamlit app. We'll just go through what this looks like here, and you can feel free to edit it as you wish. One thing to note is the requirements. The requirements tells it what to install if necessary based upon your import statements. And so I had to explicitly say Streamlit, the scikit-learn, which is all of this stuff to build the models, the NumPy, and the pandas. Just make sure that you have those in your requirements. And so let's just go through what is in here. We're importing the three libraries, Streamlit, Pickle, and Pandas. We have two functions here. One to get the data, which is the employer's database. So let me just show you the employer's database. It's a little bit different from the one that we generated in Jupyter Notebook. The one thing I've added is the name of the company because we want names. So I generated 200 fake names by using Claude. I asked Claude to do this for me. It gave me a list and I just inserted it into my spreadsheet. So opening up either in Google Sheets or in Excel, you could just insert a column, and I inserted these names so that we have some names that we can display for our app. And let's go back. So that's the first thing. I'm just loading the employer database. And then the other thing is I'm loading the model. So if you remember, we generated a model using Pickle in our Jupyter Notebook. And this takes the Pickle file, which I've included here. So this is the one that we output from Jupyter Notebook. I've included it here in my Streamlit app. So it will open that up and return that model. So I've got those two things opened up. These are arrays that have those accommodations. In fact, these are all of the features. So remember, when we built the model, we had a set of features and then the target, which was the match score. So in order to use this model to predict something, we have to generate essentially a row from the data set. So it has to look exactly the same with the exact same columns. So I've just defined that there. And then the accommodation types, remember, those are the same types that we used in our Jupyter notebook. This is the title here, Disability Employment Matching Tool. I set up some of my select boxes here so the user can select them. So I've got, just move this over. Yeah, give ourselves some room here. So I've got disability type, which are my different types, mobility, vision, hearing, cognitive, psychiatric, chronic. The years of experience, we're just going to go with a slider that goes from 0 to 30. And the default we're going to put is 5 years. We have work preference, it's fully remote, hybrid, or in office. And then industry preferences. So what happened was I tried this with the full set of employers and I was getting a huge list back for a predictor. So a lot of the employers were giving good scores for matching. So I wanted to limit the number of hits that I get. So, and I thought it made sense. If I'm looking for a job, I want to say what sector I want to look in. So you want to choose that. So that gives me the different industry sectors that the user can choose. And then our accommodations is going to be a multi-select. So you can click on this, but you can also, click other things. So you can add your accommodations. And that just shows up as a list. And then you would click on Find Best Matches. So let's just go back up here, though, and just continue to go through the code. So that sets up all the things that the user can choose. This is old, so I'm going to just take that out. First thing I do is load those two files, the employer data file, which is the spreadsheet, and then the model. So I'm calling the functions that I just talked about up above. And then again, I don't need this. So what it does is it waits until the user presses this button. So you say if ST button, find best matches. That means once the button's clicked, this is what I want to happen. So I set up an empty array. And what I want to do is first filter the employers by the industry. So remember I said I wanted to limit the number of matches. So I want to only match with employers in the particular industry sector that I am looking for a job in. So that's the first thing, is to only select those employers. Once I've done that, then I am going to iterate or loop through the employer database or data frame. And the first thing I'm going to do is set up the features based upon both the employee and the employer. From the employee, it's the inputs, the disability type, years of experience, work preference. From the employer, I'm looking at each employer one by one, and I'm going to fill in their company size, the industry, and the remote policy. And then I'm going to go generate my accommodation types. So this is similar to what we did in Jupyter Notebooks. I'm going to generate both the employee needs and the employer provides based upon the employee user input over here, and then the employer line in the database or the data frame. Then I create my input DF. So I create a data frame from this features array that I've just made. In order to do a prediction, we need to pass it a data frame. So that's what we're doing, just creating a data frame from that. And then we get the prediction. So we just do a model predict with that data frame. So that's going to give us a score. And then we add that to our results. So we append the name of the employer and then the score, which we're converting to a percentage. Okay, so this will go through every employer in the database that is in that industry. Remember, we filtered by industry, and then it just gives us a list of match scores. And then what we have here is sorting the value. So we don't want everything. We don't want to display every employer. We really want the ones with the high matches. So let's sort them. So we're going to sort the values, the scores, ascending, so biggest to smallest. This was just a debug. I was having some issues, so I'll comment that out. Don't need that anymore. If there are any results, so if there's no matches, which is highly unlikely, you're going to get some sort of a match. It won't do anything. It will tell you no matching employers. But here we'll say if the results aren't empty, again, I got another debug statement in there. Comment that out. Once I've sorted it, I say, well, what was the top score? What I found when I was testing this was that I was getting a lot of the same score. So there's a limited number of scores we're getting based upon the model. So I might get several with the same score. So I looked at the top score, and then I want to find out, well, how many matches are there with that high score? And then I count how many I've got. And what I did was decide, okay, if I've got 5 matches and they're different scores, I'm going to display each employer and then the score. Much more likely is the second if, LF, where the number of matches is between 6 and 20 that are the same score. And then we're just, instead of putting every single score, we're going to just say, okay, all of these employers gave you the score of whatever the score happens to be. And then if we've got more than 20 matches with the same score, which has happened on a couple of tests that I ran, I don't want to keep going past 20, so I'm just going to give the top 20 employers. And then otherwise we'll say no employers found. So let's just run this and say find the best matches. So in this case, top 13 employer matches, and it tells me the employers. Looks like I've got this extra, or I'm actually missing a parentheses at the end. So let's do this. I want to put closing parentheses here, I think. All right, let's try a different one. So let's say I want to do cognitive, and I've got 8 years experience. I want to be in the office. I want to work in retail. Let's see, we'll make accommodations of workspace, modified training materials, and assistive technology. And let's try that, find the best matches. And in this case, I got 15 matches with the same score. Now that we've finished it, we can commit our changes to GitHub. So click on this little icon here. If you created a fork in your GitHub, you would just say, made small updates to debugging statements. And then you can commit this and say, yes, I want to stage them, and I want to sync my changes, and this will push it. So now that updates in your GitHub repository, and you've got a copy of the Technovation one, and you can play around with it and change it as you wish. And I will also say that I really used the help of Claude to generate this Streamlit as well. Gives you a lot of help. It gave me tremendous help, but you do have to ask it a lot of questions, refine, iterate, and rethink it. Definitely GenAI is an amazing tool that will help you generate this code. However, you have to really think about what you're trying to do, what you want your app to be, and how you want to achieve that. So thank you to the Inworksiv team from Chile, Sophia and her teammates, for coming up with the idea behind this, for making the initial prototype in App Inventor. We were able to take that idea and their kind of base work to turn this into a little more detailed and complex app that can run in the web.